Welcome back. We are in the last chapter of this semester, chapter Polymer. Let's start. Without wasting the time, let's start with tutorial question number 1. Basically, we try to understand a few terms that we'll use in this chapter. So as the title, first we need to understand what's the meaning of polymer. Basically, polymer is a macromolecule which make up from a lot of the small repeating unit. However, the monomer is the one small and simplest repeating unit for the polymer. So there is two types of polymer. Copolymer means that the polymer is made up from two or more different monomer. While the homopolymer, such like the name homo, means that they only will have the same type of monomer. Okay, while to prepare the polymer, we have two types of reaction. Addition polymerization basically always involve monomer with the double bond. So means that it will involve the chapter alkene. The monomer which is the alkene, and then will form a polymer without any elimination. However, for the condensation polymerization, it will be combined two monomer to form a larger molecule, and then we'll have eliminate a small molecule such as water, methanol, and HCl. So we have two types of polymer can be produced under the condensation polymerization, which is the polyamide, and another one is polyester. Okay, now let's look at, like just now we mentioned that polymer is a macromolecule made up from a lot of the repeating unit. Okay, so this is the repeating unit, for example, and then the the polymer is made up from a lot of the repeating unit. So we didn't know what is the exactly number, so we put the n. So this is the difference between the polymer and also the repeating unit. Then as we also understand that the monomer is the simplest repeating unit. So what's the difference between limiting polymer and repeating unit? Basically, you can see that for the monomer, you will have complete number of bonds with each bond bonded to the atoms. However, the repeating unit, they must have a bond which is hanging so that they can connected with another repeating unit to form polymer. Okay, there are a few ways that we can classify the polymer. So the first type, we are going to look at the natural polymer and also synthetic polymer. So basically from the natural polymer means that it is obtained naturally. Example, we have carbohydrates, proteins, natural rubber. However, synthetic polymer is the one that we are going to prepare chemically. Otherwise, we also can classify the polymer based on their structure. So for example, we have straight chain polymer and also we have cross-link polymer. So the difference of the straight chain and cross-link polymer, basically for the cross-link polymer, normally they will add on something which like sulfur in the tire, which make it more stronger. Okay, then now let's understand the type of polymerization. As in the question number 1 of the tutorial question, we know that there are two types of polymerization. One is addition, which is always involve the alkene, carbon-carbon, double bond, and without the elimination. However, the second type of polymerization, which is condensation, basically they will combine the molecule, become larger molecule, and then it's with elimination, such as water, HCl, and methanol. So now, what is the monomer that always will involve in the addition polymerization, like we mentioned, the monomer always consists of carbon-carbon double bond, and then we need the peroxide as the initiator. While for the condensation, we may have two types, diol and also dicarboxylic acid. So as we know, alcohol and carboxylic acid react will form ester. So polymer that produce under this process will known as polyester, while another type is diamino with dicarboxylic acid, which will form amide. So we have the amide, polyamide. And as just now we mentioned that for the addition, there is no elimination. So we will only have the polymer. While for the condensation, it is with the elimination. So we except from we get the polymer, we also get a small molecule. Okay, now let's look at one example of the condensation, polymerization, and the product is the polyamide. The example is nylon 66, which will be made up from 1,6-hexane diamine and also 1,6-hexane dioic acid. So from here we can see that one of the hydrogen from the amino group will be combined with the OH from the carboxyl group to produce a small molecule. And then by combining with this, we will have a polymer. So the bond that we can see over here is amide bond. So that's why we know that this is polyamide. Okay, now look at another example, which is the polyester, and the polymer is dacron. So dacron is made up from the dimethyl tetraphenolate, which consists of the carboxylate groups, and where it will going to remove the bond will break between O and CH3, while for the diol they will take out the hydrogen. So when this combine, they will form a small molecule which is the methanol CH3OH, and by combining the bond, so we will notice that the polymer will be with the limiting unit and with the N. Okay, so at the same time actually the bond also will break over here. Okay, so from this diagram we can see that there is two monomer, monomer 1 and monomer 2. So basically we also can classify diagram as the copolymer because made up from two or more different monomer. Okay, now let's check out another polymer which is considered as example of homopolymer. So for example, the nylon 6, they have a monomer which is the 6-amino hexanoic acid. In this compound, we notice that they are both functional group, amino, and also the carboxyl group. So as usual, the carboxyl group will break out the bond in between carbon and OH, while for the amino group, the bond will break down in between N and hydrogen. So end up, we will get this nylon 6. And the molecule that eliminate is the water. Okay, now let's look at the addition polymerization. As we mentioned previously, we need the peroxide as the initiator. So this peroxide is going to break down one of the bond over here. And as we know, one bond consists of two electrons. So one electron will goes to here, and then another one electron will at the left hand side. So if try to imagine if you have a few monomer, they will doing the same things, so you will get this repeating unit. So both electron, two electron, they will connected to form the single bond. So when this happens, so we going to have a polymer. So in this case, we only show 3 molecules. So basically, actually, you can put 3 over here. But as we know that, actually, we will have more than 3 molecule monomer. that will combine together. So we get this polymer with the small n here to represent it is the structure for the polymer. Okay, now look at another example of the polyalkene, which is made up from two or more monomer, and we can note it as copolymer. So for example, we have 1,3-butadiene and styrene. So the double bond over here will be break down by the peroxide. So to form one single bond over here and one bond over here. Okay, so and then this happen again, one double bond break down. So here have one electron. So both electron combine will combine to sharing the electron. So it will form a single bond. So the double bond breakdown will become single bond over here, which is ready to connect with another repeating unit. So another repeating, because this is the core polymer, so another repeating unit must be from another molecule. So this styrene have one double bond, so it will break the bond from here and then form a hanging bond over here, and this one also the same, one bond over here. So the double bond will be eliminated, considered. So when we combine this, so we will get this structure. And then again, because this is the polymer, so we always have to write down the repeating unit and then with the N. Okay, then now we try to complete the tutorial question number 2. From the question, we are requested to draw the structure for the monomer. Okay, before we start it, maybe we can consider whether the compound, the polymer here is polyalkene, polyamide, or polyester. So basically, if you look at structure A, you didn't see the amide and carboxamide group and also the carboalkoxy group. So basically, we know that this is the polyalkene. Okay, so B also the same case, polyalkene. While for the structure C, we can see there is C double bond O and we can see there is NH. So this one is polyamide. Next one, we can see that is C double bond OO, so this is polyester. For the structure E, again, we see C double bond O and H, so this is polyamide. Okay, then now we can also try to classify whether they are copolymer or homopolymer. Okay, so for the structure A, because it is quite simple, so only consists of 2 carbon, and then we know that polyalkene is made up from alkene. So the simplest alkene always have 2 carbon, so this one supposedly will be homopolymer. While for the structure B, also the same, homopolymer. And structure C also homopolymer because in one repeating unit consists of 2 functional groups. So for structure D, because we can see that the C double bond OO, so means that we can break down like this, which is molecule 1 and molecule 2, at where we will complete the bond with the OH for the monomer 1 and H with the monomer 2. So because we have 2 different monomer, so this is copolymer. Same case happen to the polyamide, so this one structure E also considered as copolymer. Okay, now let's predict the structure. So just now the structure of the monomer. So previously the slide that we shared with you in the previous slide will be the given you the monomer and then you draw the polymer. So now we go to another stage, which is the question given us the polymer and then we're going to predict the structure of the monomer. So that means we are required to reverse the reaction. Okay, so now here we know that this is polyalkene. So this single bond, the hanging bond, have to return to here. And then this one also same. So when we have two electrons meet together, so you will going to have a bond. So single bond will become double bond. So hydrogen, chlorine, hydrogen, hydrogen. Okay, so this is done for the structure A. Then now we have structure B. So same case, go back to here and then go back to here. So we will have single bond become double bond. Okay, maybe I draw at the next part. Okay, and then we have hydrogen, 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 and also a phenyl. So C, as we know, this is the polyamide. So we are going to add the C double bond O, the OH at the C double bond O, and then CH2A and H2. So next one, just now we already say that it will make up from copolymer. It is a copolymer, so we'll have two different structure. One of it will be a benzene ring dicarboxylic acid. So we add on the hydroxyl group, C double bond O, OH. So another one will be H, O, CH2, 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 OH. Okay, then next one, the bond will break between C double bond O and H. So this case, we will get the same product as well. C double bond O, OH. This one also C double bond O, OH. And then this one will be NH2, benzene ring, and then with NH2. Okay, so these are the answer for question number 2. Okay, we still have the two question. Here we can see that we have F and then we can see the double bond. Basically, we know this one supposedly will be polyalkene, and same case happen to the G, which is also polyalkene. Okay, then now we try to predict the structure of the monomer. So as we know that if there is hanging bond, so means that this one going to go back to here. And then this one also, since here cannot be have one single electron, there must be always a double bond. So this electron will go back to here. And then this one will come to here. Okay. So then now the double bond here also same case happen. We'll break the bond, form the double bond over here, bond over here, and then this one go back to here, and then the hanging bond come back to here. Okay, then now it's time for us to redraw the structure more properly. So basically, if you can see there is two single-headed or half-headed arrow meet together, means that there will be one double bond over here. So this one, the structure F will be CH2 double bond CHCl. So and then one bond here is breaking. So means that there is another structure. Here will be CH2 double bond CH, and then this double bond breakdown will become single bond, and CH2 here will be double bond. So this is the structure for the, sorry, I think I made mistake. So let's start again. So we already stop at here, CHCl, so we'll break down here. So this CH2, another structure, okay, will be CH2 double bond, and then we will have CH. So here double bond will become single bond and then bonded to CH, and then over here we have another two single half-headed arrow meet together, so we will have double bond, and then here, yes, CH2. So at the same time, we can check that every carbon has 4 bonds. Okay, so then now we are going to look at the structure. G. So for the structure G, so maybe we can draw out the structure like this. CH2, we have a hanging bond, and then CH, then we have double bond, and then CH, CH2, we have a hanging bond. Okay. Oh yes, before we continue with the G, then from here we know that the polyalkene of F is made up from monomer 1 and monomer 2. So this is a copolymer. Okay, then now we look at the G. So for the G here, we will go back to here. And then this one we will be in here. This one break down over here and come back to here. So then now the monomer supposedly will be CH2 double bond, and then we have CH single bond because this one already break down, and then we have CH double bond, CH2. So for this one, we only able to get one monomer. So structure G or the polymer G is considered as homopolymer. Okay, so we end the video over here. In next video, we will go into discuss tutorial question 3 until question 6.